Factor trees. Our objective is to find the greatest common factor and least common multiple of two numbers. What device can be used to find all the factor pairs for a number? A factor rainbow. A factor rainbow is a way to show factor pairs in a list of all the factors of a number. A factor rainbow can be used to check whether a list of factors is correct. So for this factor rainbow, it shows us all of the factors for 48. So we've got 1 is matched up with 48, 2 is matched up with this factor pair 24, 3 is matched up with 16, and so on. What device can be used to find the prime factorization of a number? A factor tree. A factor tree is a way to get the prime factorization of a counting number. To use a factor tree, write the original number as a product of factors. So here, 36 is written as 3 times 12. Then write each of these factors as a product of factors and continue until all the factors are prime numbers. A factor tree looks like an upside down tree with the root, the original number, at the top, and the leaves, the factors beneath it. So here they are, they go down. Finding the greatest common factor. List all the factors for the numbers 18 and 30. So the factors of 18 are 1, 2, 3, 6, 9, and 18. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Now that we have a list of all of the factors of each of the numbers, we can see what they have in common. What factors are in common? 1, 2, 3, and 6 are factors of both 18 and 30. These are called common factors. The largest of these common factors is called the greatest common factor. The greatest common factor of 18 and 30 is 6. So you can see it's the largest number they have in common. Finding the greatest common factor. You can list the factors of each number and identify the largest factor, which we just did, or you can use factor trees to write the prime factorization of each number. Then identify the prime factors that the two numbers have in common and multiply them. So to do that, we made factor trees of the number 18 and 30. So here 18 is broken up into factor pairs, 6 times 3. Then this 6 is broken up into 2 times 3. So the prime factorization of 18 is 2 times 3 times 3. Then we have the number 30. It's broken up into the factor pairs 10 times 3. Then 10 is broken up into 2 times 5. So the prime factorization of 30 is 2 times 5 times 3. What prime factors do these two numbers have in common? Well, now we look at this bottom row is the prime factorization, and they both have 2 and 3 in their bottom row. So that means here are their prime factorizations. 2 and 3 are in common. We identified their prime factors. Now we need to multiply them. 2 times 3 is 6. So that means the greatest common factor of 18 and 30 is 6. What is a common multiple? A common multiple is a number that is a multiple of 2 or more given numbers. The smallest number that is a multiple of 2 or more given numbers is the least common multiple. Find the first 7 multiples of 6 and 9. So multiples of 6 are 6, 12, 18, 24, 30, 36, and 42. The first 7 multiples of 9 are 9, 18, 27, 36, 45, 54, and 63. Now we identify what numbers are on both lists. Well, on both lists, we see the numbers 18 and 36. What is the least common multiple of 6 and 9? 18, because 18 is the smallest number on both lists. Factor trees can also be used to find the least common multiples of two numbers. So find the least common multiple of 18 and 30. Well, we wrote out the same prime factorization as before. The prime factorization of 18 is 2 times 3 times 3. And the prime factorization of 30 is 2 times 5 times 3. So now we wrote them out and circle the common factors. So they both have 2's and they both have 3's. So cross out one factor in each of the pairs of common factors. So we've crossed out 1, 2 that is circled, and we crossed out 1, 3 that is circled. Now rewrite the remaining factors in a multiplication expression. So the factors that are left over are 2 times 3 times 3 times 5. The least common multiple of 18 and 30 is 90, because 2 times 3 times 3 times 5 is 90.